Hi, it's me again, Alex. Nice seeing you. Now, this will be the second part of fundamental heat transfer. So in this section here, we'll be looking into conduction through thick cylinders. So now, basically from the previous slides or from the previous podcast, we got to know that the rate of heat transfer is equals to the thermal conductivity multiplied by the area, and then with the difference in temperature over the thickness. Okay, so now from this, when you look into this diagram here, is a cylindrical diagram. Okay, so you have area. Now how are we going to take the area, the heat transfer that is across the area, that is the internal circumferential area, of the cylinder. So first thing is you have to take 2 pi r, which is equals to the circumferential length of the circular cross section here, the circumferential length of this element here, okay, of the cylinder. Okay, so that is 2 pi r, that is the circumferential length, multiplied by length L. Length L is the length that is from this end here, from the axis to the other axis. So that is the length of the cylinder. So 2 pi r L actually give you the area. K is the coefficient of thermal conductivity. Delta T here is the difference in temperature, and the thickness. Okay, the thickness here is taken as the thickness of the cylindrical wall. So for example, if we let's say for example we take this element here, the red circular ring, so the thickness is considered as dr or delta r. Okay, so that is the elementary ring thickness. So as you manipulate this equation, you get, or you will arrive to this equation. Then this is based on the thickness of the elementary ring, and this is the radius of the elementary ring that we are referring to now here. Okay, this part here. Okay, so if let's say we want to find the total, okay, temperature difference, this is not a thickness, sorry, this is the temperature difference to the thickness of the elementary ring. This is the temperature difference. So you integrate this with respect to T, and for this you integrate it with respect to the radius R. So when you integrate one with respect to T, you have a T. Substitute your upper and lower limits, so you have T2 minus T1 actually. So I have to remove this negative sign here when I replace it with T1 minus T2. Okay, so when you integrate 1 over R, you will get ln R2 minus ln R1. So that also equals to ln R2 over R1 according to your logarithm rules of logarithm. Okay, so you have this, and then okay, manipulating this, you have this formula here. So this is the rate of heat transfer through a cylindrical wall, a thick cylindrical wall. Okay, so that is how heat flows, okay, across the wall for a cylinder of this. Okay, so and then the next part is through composite thick cylinders. Composite thick cylinders. Okay, so the same thing here we have, but now what we need to do is we have multi layers here. We have layer 1, okay, and 2. Okay, so based on this, we have the temperature difference across this section, the first layer. So that is T1 minus T2. Okay, so that is the rate of heat transfer across this. Now this formula here we have proven earlier in the earlier part, the page, okay, the slides. Okay, so what we need to do is when we refer to this section here or this layer here, just replace this with T1 minus T2 and this as R2 over R1. So if let's say for example it refers to the next layer here, the temperature difference here is between 2 and 3. So you take T2 minus T3 and the radius here is between R2 and R3. So you take R3 over R2. So you form equation 3 and equation 4 from equation 1 and 2. So then after that, by adding both these equations, you arrive to this final formula here. That is the heat transfer to, okay, a composite thick cylinders, okay, composite walls. So that is more than one material here. So here I have given you 2, maybe you have 3 layers and so on. Okay, thank you for this section. Thanks for your view. Any questions or any comments, please put on the comment section below in my YouTube channel. Thank you very much for watching. See you all next time. And this will be the tutorial. Thanks a lot. Bye bye.